Welcome back. Today we are going to start with chapter 5, State of Matter. In this chapter, we have 4 subtopics: 5.1 gas, 5.2 liquid, 5.3 solid, and 5.4 phase diagram. In this video, we are going to focus on following objectives: Boyle's law and Charles' law, and then combine gas law, Avogadro's law, and then combine Avogadro, Boyle's, and also Charles' law to produce another equation which we know as the ideal gas equation. Let's continue with tutorial question number 1a. According to the Boyle's law, shows the relationship between volume and also the pressure by using a graph. So as we know, the relationship between volume and pressure is inversely proportional. So you can either plot the graph pressure versus volume or volume versus pressure. Basically, their shape are almost the same, which is inversely proportional. Next, we will look at the question 1b. A given mass of nitrogen at 298 Kelvin occupy 20 liters, so this is referred to volume, so we will place this at V1, and a pressure of 380 torr, so we will place this one. Torr is the unit for the pressure, so we will put P1. What is the volume? So the question asks us to look for the volume, which is V2, will occupy at a pressure of 4 atm. This is P2 at same temperature. So again, a given mass means that they are going to have fixed amount of the gas and same temperature. That means both amount of gas and also the temperature of the gas are constant. So means that we are going to apply Boyle's law, at where involve calculation. We are going to use the formula P1 equal to P1 V1 equal to P2 V2. So however, you can notice over here that the unit for the pressure, one is in atm and then another one is in torr. So you have to change either one of these so that they have similar unit for the pressure. So we are going to change 380 torr basically is equal to 0.5 atm. So P1 is 0.5 atm, volume is 20, equal to pressure 4, and then V2 is the one that we are going to determine. So press the calculator, we will notice 0.5 times with 20 over 4. So 10 divided by 4 will be 2.5 liter. So this is the final answer for question B. Question number 2. According to the Charles' law, state the relationship. So this time the question is mentioned, state the relationship between temperature and also volume of the gas, and where it is a bit different from question 1a. Question 1a asks us to using the graph, so we have to sketch the graph. However, for question number 2a, we have no need to sketch the graph, so we can directly state the relationship between the temperature and also the volume of gas. So volume of the gas is directly proportional to the absolute temperature at constant pressure and amount of the gas. Okay, so you must write it in the sentences. Okay. Then next, continue with question number B. A sample of 20 liters of nitrogen gas was cooled from 87 to 27 degrees Celsius. So means that this is T1 and then this is the T2 at constant pressure. So similar with what the definition of Charles' law of 1 atm. So means that this is volume 1. So again, means we need to apply the Charles' law. So the formula for the Charles law is V1 over T1 equal to V2 over T2. If you still remember, just now we say the volume of the gas is directly proportional to the absolute temperature. So absolute temperature means that the unit of the temperature must be in the unit of Kelvin. But in the question here, they give us degree Celsius. So you have to convert the unit degree Celsius to Kelvin by adding 273. So volume V1 is 20, T1 is 87 plus 273. So it will equal to 360 Kelvin. Final volume is V2. We have no idea because the question asks us to look for it. Then temperature for T2 is 27 plus 273, which will equal to 200 Kelvin. So then press the calculator. We will notice that the final answer V2 will be equal to 16.7 liter. Look at one example which is involving the combined gas law. A gas initially 4 liter volume, 600 torr pressure and 66 degrees Celsius is temperature. Undergo a change so that its final volume and temperature become 1.7. So the volume is appear again. So we consider this is the second volume. So we will label this one all as V1, P1, T1. And then this is T2. So what is its final pressure? So means that we are going to look for the P2. Assume the number of mole remain unchanged. So if we look at here, some of the parameter appear 2 times. Basically, we are going to use either Boyle's law, Charles law, or combined gas law. But in this question, because of the 3 parameter, volume, pressure, and temperature are given, so we are going to use combined gas law. Again, when you look at the question here, you will notice the temperature must be in the unit of Kelvin by adding 273. The unit of pressure, if you don't want to change, then it's okay. If you want to convert them to ATM, that is okay as well. So by substituting the value in to the combined gas law, P1 V1 over T1 equal to P2 V2 over T2, then we will get the pressure in torr 1.31 exponent 3 torr. Next example here is involve Avogadro law. Calculate the volume V at STP. STP means at 0 degrees Celsius and 1 atm by 0.2 mole of carbon dioxide gas. So as we know, when at STP, no matter what is the gas, 1 mole always equal to 22.4 decimeter cube. So because of in this question here, we only have 0.2 mole of carbon dioxide. So we are going to do the comparison. So that from here, we will going to know 0.2 mole of carbon dioxide gas actually will occupy 4.48 liter of carbon dioxide. Okay, in this slide, we are going to learn about ideal gas equation. So what kind of gas we'll consider as ideal gas? So generally, we say if the gas obeys all the gas law that we discussed before, for example, Avogadro, Boyle's law, Charles law, and also combined gas law. And now, if the gas also obeys the ideal gas equation, we will generally say that the gas is ideal gas. So ideal gas always will behave ideally at low pressure and high temperature. Ideal gas equation is derived from Boyle's law, Charles law, and Avogadro's law. So we try to arrange all the parameters of the volume at the left-hand side, and then we combining it by putting a constant. So this constant is R at where it is known as gas constant. After we arrange this equation, we will get PV equal to nRT. So this is the ideal gas equation. So you all have to remember this formula, PV equal to nRT. This ideal gas is important because it can help us to determine the density. Okay. As we know, from the number of mole here, we are able to expand it become mass over molar mass. So by rearrange the formula, when we have mass, we have volume, we're able to determine the density. So at the same time from here, when the number of mole, we expand it become mass over molar mass, we can determine the molar mass. From the equation, PV equal to nRT, temperature, number of mole, pressure, and if we want to find the concentration, is number of mole over the volume. So number of mole also in the equation, volume also in the equation. So that's why ideal gas equation is very common use when we involve in the question calculation of gases reaction. Okay, at the same time, we have to know what is the gas constant. By referring to the table below here, we have three values of gas constant. Among these three, we always use 0.08206 liter atm per mole per Kelvin. Because of we always use this value of gas constant, therefore we have to make sure when we substitute the value into the PV equal to nRT, we have to make sure the unit of the pressure always in atm, atmosphere, and then the volume of the unit of volume always in liter, and then again and again, temperature always is in the unit of Kelvin. Now let's continue with tutorial question number 3. A 0.112 gram sample of gas occupy 81.8 centimeter cube at temperature 127 degrees Celsius at 1 atm. Calculate the relative molecular mass. So basically question number 3 are different from question number 2. So question number 2, basically you can see if volume are given, they will have two volume at different condition. Okay, but in this question, all parameter given is only appear once. So that's why we know that we are not going to use Boyle's law, Charles' law, and also Avogadro's law. And then another key point for us to know that we are going to using the ideal gas equation because the question asks us to look for the relative molecular mass. So if you involve with the relative molecular mass, so we are going to use ideal gas equation. So ideal gas equation is PV equal to nRT. So R is the gas constant, and then the gas constant that we always use is 0.08206 liter atm per mole per Kelvin. Okay, so when we focus on the unit here, we will have the idea that we need to convert the 81.8 centimeter cube to liter, 127 degrees Celsius to Kelvin, and then the pressure 1 atm we can maintain. Okay, before that, let us rearrange so that we can get the relative molecular mass. So PV equal to nRT. Then number of mole we can expand to mass over molar mass. Multiply with RT equal to PV. So after we rearrange, we will notice that molar mass is equal to MRT over PV. So when we substitute all the value in according to the correct unit, we will get the molar mass is 44.94 gram per mole. However, the question is asked us to calculate the relative molecular mass, so means that they supposedly have no unit. So we are going to apply what we learned in chapter 1, relative atomic mass equal to, okay, so but because of this one is molecule, so we are going to change the atomic to the term of molecular mass equal to mass of one molecule over 1 over 12 times with mass of one carbon 12 atom. So then we will put 44.94 over 1 over 12 times 12 AMU. So AMU and AMU cancel out. 1 over 12 with multiplied by 12 equal to 1. So end up the relative molecular mass is 44.94. Tutorial question number 4. An experiment carried out to determine the molar mass. So basically we need to know what is the molar mass for an unknown gas. The pressure is given in the unit of Pascal. So we are converting them to ATM, at where we are going to, after convert, the value is 1.0963 ATM, and its temperature is 15.9 degrees Celsius. After convert to Kelvin, the temperature is 288.9 Kelvin. Given below is the data obtained in the experiment. When we get the difference of the mass of antibulk and mass of gas, we are able to determine the mass of gas, which is equal to 1.036 gram. But then we minus the mass of bulk with water with the mass of empty bulk, we are going to get the mass of water. But actually we don't need to know the mass of water. Then the mass of water given you after you do the subtraction is 507.449 gram. But basically actually we need to know the volume of the water. So we are going to use the density of water given in the question here to find the volume of water. So after we do the calculation, the volume of water is equal to 507.5 milliliter, and then we need to convert them to liter, which is 0.5075 liter. So as we know, majority of the parameter given here only appear once, means that we are going to solve this question using PV ideal gas equation, PV equal to nRT. So rearrange mass RT over molar mass. After then we rearrange. If we want to know the molar mass of the gas, we are going to use mass of gas multiplied by gas constant, temperature of the gas, and then over the pressure and also volume of the gas. So mass of the gas is given, is not given, so we already calculate the mass of the gas over here, 1.036 gram, and then the R value is a constant, which is 0.08206 liter ATM per mole per Kelvin. Okay, so if you look at all the parameter, we already convert to the unit of liter, ATM, mole, and also Kelvin. So after that, the temperature is given 15.9 gram, and we convert it to 288.9 Kelvin. Pressure given in 111.052.2 Pascal. After convert is 1.093 ATM. Volume of the water is consider volume of the gas as well. Why we consider like this? Okay, because the volume of the water is volume of container. So the volume of container also will equal to volume of gas. So all these, they are similar, so which is 0.5075. So by substitute all the value into the formula here, you will get the molar mass is 44.12 gram per mole. Question number 5. Aluminium oxide decomposed to aluminium, formula is Al, and oxygen gas O2 at high temperature. Write a balanced equation for this decomposition reaction. So, aluminium oxide, solid, aluminium also solid, and oxygen is in the physical state of gas. So this is the balanced chemical equation. We proceed with question B. A sample of 6.04 gram of aluminium oxide decomposed completely at a temperature 72 degrees Celsius, and then with the pressure 183 torr, calculate the volume of the oxygen gas. So in this question, you are given information about aluminium oxide, but the question asks us about the oxygen gas. So indirectly, that we know that we are going to use stoichiometry comparison. Okay, so before we then, in this question, it's very obvious we are going to compare aluminium oxide and also oxygen gas. Because information given is aluminium oxide, question asks for oxygen gas. So when we want to do the comparison, we have to compare in terms of number of mole. So before we start to do the calculation, we have to get the number of mole for the aluminium oxide using the formula mass over molar mass. So after you press the calculator, you will notice 6.04 gram of aluminium oxide actually is equal to 0.059 mole of aluminium oxide. And then we compare with the chemical equation. 2 more aluminium oxide will going to produce 3 more of oxygen gas. So if we only have 0.059 mole of aluminium oxide, so means that we are going to produce 0.0885 mole of oxygen gas. So because oxygen is in the gas, and then in the question you are given temperature and also pressure. So we need to find out the volume. So in this case, you will have the idea that we are not going to use Boyle's law, Charles' law, or even Avogadro laws. But in this case, ideal gas equation is more probably PV equal to nRT. So pressure we have, volume is going to determine, number of mole also already calculated, R value we also is a constant, temperature is also given. Only need to alert that is the temperature we must convert it to unit of Kelvin, and then the pressure, the torr, we have to convert to the unit of ATM. Then the R value is 0.08206 liter ATM per mole per Kelvin. So then we substitute all the value with the correct unit into the formula PV equal to nRT, and then finally you will notice volume of the oxygen gas is equal to 2.343 liter. Okay, this is the final answer for tutorial question number 1 until number 5. So in next video, we will going to continue with the Dalton's gas law. So see you in next video. Thank you.